we are starting Chapter 6. And Chapter 6 is about systems of equations. Alright, so the first thing we need to talk about before we actually get into this section is, what is a system of equations, right? System of equations is two or more equations with the same solution. Now, there are three different ways that we can solve these systems, and I want to talk about those. So the first way we can solve a system is by graphing, hence the graph stickies you have on your desk. Way number 2 is by what they call substitution. The third method is what they call elimination. Now, I told you this chapter has 4 sections in it. So today we're doing 6.1, which is graphing. 6.2 is substitution. 6.3 is elimination. And 6.4, my favorite of them all, is real life situation problems, which mean word problems. How exciting, right? Got a whole week of them, so it's going to be fun. All right. So today we are actually going to start with 6.1. Solving by graphing. All right. When we solve by graphing, there are 3 possibilities of what could happen. Possibility number 1 is when I graph the 2 lines, so there's one and there's a second one. When I graph those 2 lines, they intersect each other, and that point where they intersect is the solution. So if I have a system where the 2 lines intersect, it has one solution, which that solution is always written as a coordinate x and then y. And we call this type of system an independent. So that's option 1. Option number 2 is if when I graph my line, my second line falls exactly on top of my first line. So they are the same line. This type of system is called dependent because they depend on each other to be the same. And if I had that line right on top of the other one, how many times do you think they cross? Infinite. Yes, so our solution is infinitely many solutions. Good job, Jackson. Option number 3. Option number 3, when I graph my first line, and then I graph my second line, and those lines never, ever cross. What type of lines are those? Yes. If I have parallel lines, and they're never going to cross, that means I have no solution. And that type of system is called inconsistent. So that's the 3 possibilities for today. That's our 3 possibilities for today. We're going to have an answer, could have infinitely many solutions, or we could have no solution. Seems pretty easy, right? All right, so here we go. We're going to jump into example number 1. So I'd like you to put example number 1 And give me your very first sticky graph. Make sure you put Y to the sky and X on the right. Just peel it off. You're good. Alright, so everybody's put their first sticky graph under example number 1. So when we have a system of equations, our book writes them one on top of the other one. Typically, they usually have this bracket thing that kind of connects the two together, but our book doesn't write it that way. So what we have to do is graph each one of those and find out where they cross each other. Seems pretty easy, right? Graphing the first one. There is no y-intercept, so that means I have to start at the origin, right? And then my slope here is 3, which is 3 over 1. So I'm going to go up 3 to the right 1 and put a dot. Do it one more time, up 3 to the right 1 and put a dot. Connect your dots. Now, because we want to make sure we know where they're going to intersect, make sure you draw that line using your straight edge I provided you. Right? Draw that line for waves. Second equation. The second equation says that I start at 0, 6 on the y-axis, right? So 1, 2, 3, 4, 5, 6, and put a dot. My slope this time is -3, or -3 over 1. So that means I go down 3 to the right 1. Down 3 to the right 1, and connect my dots. These two lines intersect at that one point, right? Our solution is that point, so we have to write our solution as 1, 3. That's it. Okay? So, but you can see that if you're not using a straight edge, that it's not going to be as easy to find out where the two of them are intersecting, right? Need to make sure you use your straight edge today. Okay? Huh? All of them? Don't give me that strange look, Miss Beckle. All right. Here we go. Example number 2. Again, give me another sticky. Y to the sky and X on the right. Yep, example number 2. Say I have y equals 1/2 x plus 6. And let's go with y equals a -1/2 x plus 2. All right, so we're going to graph the first one, which means we start where? We start at the y-intercept, which is the last number, or 0, 6. 1, 2, 3, 4, 5, 6. Then my slope is 1/2, which means I'm going to do what? Up 1 over 2. Up 1 over 2. Up 1 over 2. And go ahead and connect your dots using your straight edge. You want to make sure you extend it. Use that straight edge and extend it, because who knows where this next one's going to go. All right. How do we graph the second equation? Start at 2, or 0, 2 on the y-axis. Very good. And this time our slope is -1/2. Good. We're going to go down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. Connect our dots. All right. So these two equations, they intersect at this point right here. What is that solution? Negative 4, 4. Very good. All right, so before we keep going, questions so far? We're doing okay? All right. Let's do the third sticky I gave you, example number 3. Again, when you put that in there, make sure y to the sky and your x on the right. Maybe, we'll see. All right, let's say I have 2x minus y equals negative 5. Second equation is going to be negative 2x minus y equals negative 1. All right, so in order to graph this, what do we want to do? Yeah, so we're going to move it around to y equals mx plus b, right? Let's start with the first one. I'm going to put it down here so we can move it around. I have 2x minus y equals negative 5. To get y by itself, what's the very first thing I have to do? Minus 2x to the other side. I agree. So I have negative y equals negative 2x minus 5. Then, is y by itself right now? So I got to divide everything by a negative 1. I get y equals a positive 2x plus 5. Let's graph that one. Where do I start? Good. 1, 2, 3, 4, 5. I agree. 0, 5, or 5 on the y-axis. My slope is 2, which means I'm going to go up 2 and over 1. Up 2 and over 1. And connect my dots. Second equation. I have negative 2x minus y equals negative 1. Again, to get y by itself, the first thing I have to do is add 2x to the other side. That leaves me with negative y equals 2x minus 1. Then what do I have to do? Good. Divide by a negative 1. Nice job. Get that out of my way. We have y equals negative 2x plus 1. So to graph this one, where am I starting at? 0, 1 on the y-axis. My slope this time is negative 2 over 1. So from this dot, I go down 2 and to the right 1. Down 2 to the right 1. And go ahead and connect your dots using your straight edge. So you'll notice these two lines intersect, gentlemen, right here. Good. Negative 1, 3. All right. Questions? 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 All right. So if there's no questions, this is what I want to do. I am going to be giving you graph paper to use today, right? So that you'll have a grid. You'll be able to use your straight edge, all right, in order to make them intersect. So I'm going to go ahead. Your homework is on page